the video. Get a full screen here as well so I can see what you're seeing. There we go. I guess we're all set. All right, so got like 4 or 5 topics left to cover for what I'm going to grade you on in terms of total content by the end of the semester. I'm hoping that I can challenge a bunch of you if you get very sound with it. We all make mathematical mistakes, careless mistakes here and there. The idea is to prove to me that you understand conceptually what's going on and that you have the pre-cal algebra 2 skills to manipulate and work with the quantities, whether nominal or grand. There we go, nominal, word of the day, right? Small amount, trivial. It kind of reminds me of dx. All right. So I've got this all prepared. I'm going to do the videos in separate form. I'm going to do a topic at a time, stop the video, and upload them that way. So here's the arc sine of x. And as I say, I'm not worried in the slightest that you'll have any difficulty taking the derivative. It's virtually the same as taking the derivative of the square root of f of x. Follows the same kind of format. So it takes a little bit of memorization. My concern is your background, whether or not I ask you something about the arc sine of, do you know what goes in the parentheses and do you know what comes out of it? Notice I didn't tell you yet. And so if you don't, pause and think about that, the arc sine of, can you come up with this gets me that? If not, then you got some gaps, we got to fill them. And that's the second half of the video. I'll try to get you up and running on that. Over time, try to develop the skill to work with this function that should have done before. But I understand, especially with pandemic, and for those of you who were taking trig in our sequential format, probably didn't get too far. Half-hour classes, remote. I know by uploading it, I felt pretty good with my pre-calc classes last semester because we finished everything before midterm, which meant it was still worksheets. It was still banging them out. A lot of you didn't have that experience. So we'll try to make up some ground and help you along with that. All right, so how do you get the derivative of y equals arc sine of x? Let's see, maybe I could put the video here a little bit closer, centered, and make me out of the way there. Yep, I'm out of the way. I'll try to write so I'm not, it's awkward, I gotta tell you. All right, so the method here is implicit differentiation. So we do the inverse operation, which is I'll write arcsine in the other notation system, and I'll stay here so that we can see sine inverse of y equals x. I'm sorry, sine of y. That's why I say it's awkward doing this, talking and looking back and forth. So the arcsine, the inverse operation comes to the other side. What I was referring to is that means the same thing. All right, sine inverse is the same thing as arcsine. So the sine of y equals x. Now, you got to know what y stands for. In this notation system, that's an angle. So let's get a drawing going. That's the angle. So what is over here? Well, that's the ratio. Now, it doesn't look like a ratio. It certainly does if I put a 1 over it. And so then you got to ask yourself fundamentally, what's the sine ratio? Well, opposite over hypotenuse, right? In the unit circle, x is just that height. Okay. Now, I don't know how many of you are familiar with doing these questions from the Pythagorean relationship. It's much easier. You certainly don't want to be saying a squared plus b squared equals c squared manipulate. It takes too long. All right. So let's just get you up and running here. So that's 1. So that area is 1. This side is x, which is the square root of the area. So that's x squared. The smaller sides add up to the larger. So 1 minus x squared is this area, and therefore that is 1 minus x squared, which is the square root distance, which is now adjacent divided by 1, gets me solving for y. So I've kind of run out of room here, so I'll write it here. So I now know that y, which is the I didn't take I'm sorry, I have yet to take the derivative of this implicitly. Okay, so I've got the triangle, I've got my values here, I've got this triangle, 1 minus x squared. So forgive me, I have not yet taken this in terms of implicit differentiation. So let's go back here because we're after the derivative, right? I was just solving for this triangle right now. All right, so let's go take the derivative. Pause the video. Do you have the skill to take that? I hope so. It's awkward because you haven't done it much and it's hard for you to get a feel for those values without us actually working with some numbers, but that takes so long to actually do that numerical work. Hopefully in the second half, I'll be able to make some videos once we get up and running so that you can trust the calculations that I'm looking at. But that's for the future. All right, so implicit differentiation, derivative of sine is the cosine of y prime, that's hard to get a feel for, I know, equals 1. So now we know that y prime is equal to the secant, or 1 over the cosine of y. Remember, y is the angle here. We now have the cosine function adjacent to hypotenuse. And so the cosine is this divided by that. That is the cosine. So y prime equals 1 over the square root of 1 minus x squared. Okay? All right. So now I said this is pretty basic. So let's play with it a little bit. So let's look at the derivative of y equals arc sine of a function. I'll put some in a moment, right? And I want to do that for you right now to show you what it is. And then I hope you can see that it's very similar to doing the ln of f of x, square root of f of x, sine of f of x, chain rule. All right, well, I'll stick with ln of f of x and square root of f of x because you get a sense of denominators with that. So what is y prime here? Y prime is f prime of x. Looks like a familiar start, doesn't it? Square root of 1 minus f of x. Yeah, I'll put it in brackets. Squared. That's it. All right, there's taking a derivative. Now, obviously, going in the other direction with u substitution, and it takes some practice. Am I looking at arcsine? Arctan is going to come into play as well. I got to do a video on arctan. Same process. So there's like 5 derivatives that look similar. All right, and so integrating is going to be an issue. It's going to take some practice, and maybe 3 weeks from now, that's all we'll do for one homework is maybe 20 problems where they're all mixed up. Arctan, arcsine, square root of x, so we can get some facility with that. I think that's a good way to go. But right now, let's just practice. I'm going to have to do a little erasing here. Let me get an eraser. Let's do 3 arcsine problems in a row and see if you can get the kind of the pattern down. And then I'm going to go over to the other board and we're going to talk about the actual calculation arcsine, because if there's a problem with writing the equation of a line tangent to arcsine, I don't think it's the calculus. I think it's going to be not knowing what you're dealing with in terms of calculation. So here's one. How about, can you give me y equals the arc sine of x squared? Okay, you pause the video, try it. So y prime is equal to the derivative of x squared over the square root of 1 minus whatever's in the parentheses gets squared. Yeah, I think the mechanics of that aren't going to be too hard for us because of the work we've already done in class with the other functions that are similar in nature. All right, so let's try another one. Let's take the y equals arc sine. I'll write it in the other notation. Sine inverse of e to the 2x. Okay, so what do we have? Sine inverse of e to, I have the derivative. So y prime is the derivative of what's inside, which is 2e to the 2x over the square root of 1 minus what? E to the 2x squared, e to the 2x squared. I hope you remember your rules, multiplication, e to the 4x so that you're not running off the page. Well, I would just do one more, and then we'll go over and look at the arcsine from a graphical, symbolic, and historical perspective. A little history here. All right. I'm guessing about the history. Y equals the arcsine of 2. Okay? We take the derivative of 2, which is 0. That was a trick question. That's a constant. Okay? In fact, it's undefined. I wonder if you know why it's undefined. Hope so. All right. Didn't mean to do that, just popped in my head. Get a little squirrely here. All right, so let's look at one last one. Y equals the arcsine. Arcsine, there's a difference between capital A and little a, and I don't know what it is. I'll have to look at that. Let's see. Let's do f of g of x. Yeah, since that gave us trouble on a previous test. So I take the derivative of f of g of x, which is kind of like saying sine of 2x. You know, that's an f of g of x. So we take the derivative, which is f prime of g of x, kind of like saying cosine of 2x, times g prime of x, all over the square root of 1 minus f of g of x, all in some parentheses. Let's bracket, well, I suppose I could put it there, but let's bracket it and square. All right, and since we're going to do them the rest of the term, I think that's enough practice for now. Now let's just talk about what the heck you're looking at. All right, so earlier I said, do you know what's in the parentheses? It's a ratio. All right, so here's the arcsine. I'm sorry, here's the sine function, right? Sine function. And inverses are always symmetric to y equals x. In other words, this point here has to be the same distance away with respect to this line that splits right down the middle between, I get tired here. I'm not saying things quite properly, but let me just graph it real quick. So distance there would be here. And so the arcsine looks something like this. Now, why did I stop there? Because the arcsine deals with the ratios. And you can never be bigger than 1. Okay, so the inputs are the ratios, -1 to +1, and the angles are now on your y-axis, because normally you go angle to ratio, now you're going ratio to angle. And doctoring that up, this is the graph of the arcsine. Okay, that's what it looks like. Probably never going to have to work with it again in terms of what it looks like. But what you are going to have to work with is values. This gets me that. This gets me that. You know, finding the coordinate when you're trying to get a tangent line to the arcsine. That's where I'm worried. So this is just a tutorial that, you know, I think probably going forward, the only thing you have to play is probably this each night for 4 or 5 nights in a row and follow what I'm about to say. Okay? That's half a circle. Half a circle. Okay? And I think historically, the terminology is that looks like an arc. Okay? That looks like an arc. And sine is all about altitudes. Sine of x. So the arcsine is easier to do than the arc cosine, because even though arc cosine is all about widths, you still put the widths on a vertical axis. So that's why it causes a little more trouble, I think. Right, so what's the input now? The input are the values on this ruler. Okay, I am putting all of the ratios, the arcsine ratios, the range from -1 to 1. And then we are going to say, okay, what angle produced the number 1? 90. So the arcsine of 1 is 90. The arcsine of root 3 over 2, 60. Okay, and I'm going to change these to radians here in a moment, because this is the 5 minutes you want to look at every now and then if you're going to be able to write equations of tangent lines to arcsine. All right. And root 3 over 2 is approximately 0.87. I really would like you to have a feel for that number. You throw it around a lot in trig, and you're going to throw it around a lot the rest of the term. It's nice to know the size of root 3 over 2. It's about 0.87. 0.22, root 2 over 2 is about 0.71. These are approximations. Okay, but you should be familiar with them. And you will be if you play this part of the video just 3 or 4 nights in a row. All right, so in a 45-degree angle, you get root 2 over 2, about 0.71, you know, 0.7 and 0.7. If you square it, you get 0.49. You get 0.49. And if you add those two things up, 0.49 and 0.49, you're pretty darn close to 1. Okay, this is exact though. Root 2 over 2 and root 2 over 2. So I suppose if you square that, oh yeah, you get a half. And if you square root 2 over 2, 2 over 4, oh, you get a half, and a half and a half is 1. That's exact. Okay, so when you have the sine, arcsine of 1/2, it came from, arcsine of 1/2 came from a 45 degree, I'm sorry, arcsine of root 2 over 2 came from a 45. Arcsine of a half came from 30. Why? Because the sine of 30 is a half. Hopefully you're familiar with that one. Arcsine of a half is 30. Arcsine of 0, 0 degrees. Arcsine of minus 1/2, minus 30 degrees. Arcsine of minus root 2, minus 45. Arcsine of minus root 3 over 2, minus 60. And arcsine of -1, negative 90, which is the same as minus pi over 2, minus pi over 3, minus pi over 4, minus pi over 6, 0, pi over 6, pi over 4, pi over 3, pi over 2. A lot of patterns in here. All right, so if I wanted to write the equation of the line tangent to, last thing I'll do, tangent to 1/2, comma, we won't say. X equals a half. All right, well, you got to take this arcsine of a half. I hope you see it over here. Arcsine of a half is pi over 6, 30 degrees, because the sine of 30 is a half. All right, so we got our coordinate now. X minus 1/2 plus pi over 6. And this is where I'm worried. That's where I'm worried, right there. All right, for folks in the class. Now we got to get the slope at 1/2 for the arcsine of x. Well, we just found that the arcsine of x is, the derivative is 1 over 1 minus the square root of x squared. And in this case, our x is a half. 1/2 squared is 1/4. So that is 1 over the square root of 3/4. And so that is 1 over the square root of 3 over 2. Oh, so it looks like our slope is 2 over root 3. Okay. All right. I hope I didn't butcher anything there, because talking and doing at the same time. And I find that the more I do that, as I go up the ladder here in age, start making more careless mistakes, but hopefully I didn't butcher anything. All right, so this is where I think you're going to probably have to spend your time. You got the cheat sheet, and you're going to have that until the last test of the year. You're not going to have it. The very last one, you won't have it. Up until then, use as much as you want. Hopefully, the more you use it, the less you have to use it. As in, oh, I don't have to look up that anymore. And that's a big goal too. Working knowledge in this discipline that hopefully will stay with you for a while. All right, that's it. See you on, I think I'm going to upload this for Sunday night as a homework. If I can get Canvas to work again. I think I'm still out of Kurzman. All right, bye-bye, and the meeting and the video.